Hello, everybody, and welcome to the Week 14 introduction video for Math 1220 online. So we're almost done with the semester. I'm sure we're all looking forward to summer, but try and keep with it for these last 2 weeks. So your exam 2 grades should be available by this Tuesday evening. And when they're ready, I'll post an announcement on Canvas with more information, like averages and so on. There are 2 assignments left. So like I said, almost to the finish line. So just keep on going through these last 2. They're sort of fun. They're both in both topics we're doing these last 2 weeks. They're sort of more or less standalone. They don't sort of use too much of the stuff we did before. So in particular, they don't use like, we're sort of done with the stuff we were doing with Taylor's series for now. And these are sort of 2 topics that just, I mean, they're interesting. They build towards Calculus 3 and sort of they're important things for other applications, but like they don't really build on all the stuff we did earlier in the semester. So even if you were struggling or you're still catching up on earlier stuff, if you get back into it, you should be able to work through these 2 assignments. Good. And so the final reminder is the final exam can be taken anytime in finals week. That's Thursdays, April 27th to Wednesday, May 3rd. And do get that scheduled sooner rather than later so you can get the time you're looking for to take that exam. Okay, so some words about the mathematics this week. So we're doing sections 10.1 to 10.4 in the textbook. And this is on the theory of conics or conic sections. This is a little bit of a silly name. Let me tell you what a conic is. So a conic just means either an ellipse, a parabola, or a hyperbola. So this is an ellipse. It's like a squash circle. Parabola is like this shape. It's sort of like the equation y equals x squared. So it sort of goes sort of off to infinity up here. And then a hyperbola is like x squared minus y squared is equal to 1, or y squared minus x squared is equal to 1. So it looks something like this. So it has like these 2 branches, and sort of like there's like sort of these asymptotic lines that the 2 branches approach. So these are sort of 3 important shapes described by degree 2 equations. So equations like polynomial equations in x and y that only use like powers 2 or lower. You might ask, why are we studying these things? Well, and these are sort of some of like very elementary geometric objects. I mean, if you sort of only use degree 1 equations, you just like you describe lines. So this is sort of like the next most complicated thing after lines. So it's a little bit more complicated than lines, but like they're not too complicated to understand. Somehow they sort of they show up all over the place, both in mathematics and in sort of applications of mathematics to other fields. So it's nice to sort of have a firm grasp of like the properties of these shapes. Sort of for various things later on. So the reason they're called conics is because you can get sort of any one of these shapes by slicing a cone in the right way. So if you want to get like so here's like a picture of a cone in 3-dimensional space. Like you do like a cone up and then a cone down sort of together. And so for example, like if I want to get an ellipse, I could sort of slice it across like up here, and that would sort of give me an ellipse. If I wanted to get like a hyperbola, I could sort of like slice it across like this. That would sort of give me a hyperbola. Okay, and sort of I wanted to get okay, well, maybe I'll stop describing them there, but they're conics. Conics are things you get by slicing a cone. That doesn't matter. So don't worry about this part. The textbook starts sort of by describing this, but I mean, it really doesn't matter for anything we're doing. Okay. So what are the key ideas for this week? Well, in sections 10.1 to 10.3, what you really develop are 2 things. First, you sort of describe these shapes, giving a geometric description using things that might not be too familiar, depending on what you've seen before. Might be familiar if you've taken a physics class before, but these are sort of the terms focus, eccentricity, and directrix. So this is like a little bit, if you haven't seen this before, this will seem like a little bit of a funny way to describe a shape. Like sort of, you basically, you sort of give a line, you give a point, and you describe a shape as sort of like being like the points that sort of satisfy some property with respect to their distance from that point and their distance from that line. And you might ask, like, why not just describe it with an equation? And that's in the end, what you'll do is you'll, like, in sections 10.2 and 10.3, you'll find sort of like algebraic, like, equations like x squared plus y squared is equal to 1 and things like that give you an algebraic description of these shapes. The reason for the geometric description is that somehow, like, more than the equation itself, the notion of sort of what is the focus point or foci point, what are the eccentricities, and what is the directrix? I mean, somehow these are actually sort of the key things if you want to use these shapes, like, for example, in optics. So if you want to understand, like, how to use like a parabola to sort of like build a radio telescope, then like what you care about is like where the focus is. So somehow, even though like this is going to seem a little bit like a funny way to start describing a geometric object, it's because it's isolating what are the key parts. So what are the key properties of this object, like when you actually want to use it to like build something, for example. Good, but so then, I mean, so like the key thing then is to understand how to go back and forth between like the geometric description via these properties of focus, eccentricity, and directrix, and the algebraic description, sort of just using the equations, like how if I give you the focus and directrix, like how you can sort of then find an equation. Sorry, how if I give you these three things, you can then find an equation, or if I give you an equation, how you can go back and find sort of these key pieces of information. So that's what you'll be doing in sections 10.1 to 10.3. In section 10.4, you're going to give a sort of different way of describing it. So you're going to give a parametric description. That means you're sort of describing like basically how you would, if I sort of took your pen and put it on the paper, like how you would trace out one of these shapes. So you're sort of tracing out the x and y coordinates. So you're giving like the x and y coordinates as a function of one variable. So you're parameterizing these curves. So 10.4 sort of talks about parametric descriptions of curves in general, but really with a focus on sort of parameterizing, like in the examples, there's a focus on parameterizing ellipses, parabolas, and hyperbolas. And so once you have a parameterization, then you can also start to do calculus with it. And the kind of calculus operations you do there sort of start to build towards the kind of things you'll do in calculus 3, where you're doing sort of calculus of sort of applied in higher dimensions. Okay, so again, though, like the main thing here is you want to understand the relation between these different types of descriptions. So that's sort of what like the exercises build towards, and that's sort of what you'll be working on mostly this week, is sort of understanding how you go back and forth between these three things, really mostly emphasizing on these two things, and then sort of a little bit on how you go back and forth from this parametric description to these, but then how you also use this to do some calculus. So one thing, just to finish up, let me note there is no departmental video for this. So if you've been following along week by week using those sort of standard departmental videos, when those were made, these sections were not part of the syllabus. So there aren't any departmental videos about this, but Matt Cecil's alternate videos are posted for this. And these are also excellent videos. So if you haven't been following along with Matt's videos and you've been using other ones, this is a good chance to take a look at them. And they're also excellent, an excellent resource. And of course, then you always have the textbook. Okay, so that's everything I wanted to say. I hope I will see some of you in office hours this week or hear from you by email. And again, I will post the exam grades hopefully by Tuesday evening, and you'll get an announcement when those go out. Thanks, everybody, and have a good week.